Hi students, today we are going to see the basic concept of electric field. The previous classes we have learned that the force exerted by a charge on another charge or the force exerted by a single charge by multiple charges and its magnitude. Today we are going to see that how an electric field is formed and what are the significance of an electric field. First, let us consider an electric charge is kept at a point origin O. Now see, this is the point origin O, and here a charge is kept here. What is the charge? The charge is Q. And then another point P, this is the point P, another charge Q0 is kept, and the distance between the O and P is taken as its position vector, that is R. So OP is the position vector R. Now, as we have already learned that when a charge is kept nearby another charge, definitely there will be a force acting on charge Q0 by the charge Q, and the direction of force acting on this charge Q, this is the force, direction of force acting on the charge Q. And we have already learned that what is the magnitude of that charge exerted by charge Q on charge Q0. And here, now the question comes, what will happen if the charge Q0 is removed from that at the point P? If the charge Q0 removed from the point P, then there is nothing. Then if there is nothing, then how the charge Q can exert a force on it? Or what does it mean? How does it happen? So, in order to answer this question, the scientists come to conclusion that, and they introduced another term, electric field. That means here the charge Q, okay, the charge Q is called as source charge, and charge Q0 is the test charge and source charge. If the force exerted by a source charge, okay, that means here when the charge, and for our convenience we consider that these both are positive charges, then the repulsive force will be there between these two charges, and then the charge Q0 brought under the influence of the charge Q, and the charge Q will exert a force on charge Q0 definitely, okay, and then this will be the direction of this the force exerted by the charge Q, and the magnitude of the charge or the magnitude of the force exerted by the charge Q as per the Coulomb law. Then we know that F is equal to 1 by 4 pi epsilon 0. Then here Q is the source charge and Q0 is the test charge divided by the distance between the charges, that is the R, and the unit vector R. So this is the magnitude of that force exerted by the charge Q on charge Q0. And now what happened is the charge Q is removed from there, then there is nothing, and the scientists, they introduced another term, the electric field. That means this charge Q, the charge Q produces electric field lines around it, okay, electric field lines around it. So when any charge is brought nearby this charge Q, okay, it will be under the influence of that electric field lines. Okay, since both they are same charge, like charges, repulsive force will be there, and so therefore the electric field line or the electric field is denoted by the letter E. And what is the magnitude of that electric field E? E is equal to the magnitude of the force exerted by the charge divided by the test charge Q0. E is equal to F divided by Q0. And here this electric field it has the direction of the electric field is same as that of the direction of the force. Okay, that means the electric field and force both have the same direction. So since this electric field it has direction, this is the magnitude of the electric field, then the electric field it has magnitude and both direction. So it is a electric field is a vector quantity. Okay, and if the test charge Q0, if it is considerably large, okay, the magnitude of the charge or the charge is, so what happens if this charge Q0 is brought nearby this source charge? What will happen? Under the influence of the electric field lines produced by the Q, the electric field lines are produced around this charge in all directions. Okay, so if this test charge Q is brought nearby the charge Q anywhere, then what will happen? So this force will act on the test charge, and the magnitude or the force will be, the amount of the force will be high, so that it will remove this test charge from its surrounding. So in order to avoid this situation, the test charge is taken is infinitesimally small, so that it does not affect the position of the charge Q0. So then electric field can be redefined as E is equal to, so we will give a limit charge test charge Q0 tend to 0. Okay, then E is equal to F divided by Q0, and this is the equation of the electric charge. The unit of electric field is, since the unit of SI unit of F is equal to Newton per, and what is Q is the charge, then the unit of charge is Coulomb. So the unit of electric field is Newton per Coulomb over Newton Coulomb inverse. This is the unit of electric field. Now what will be the magnitude of the electric field produced by a unit charge? The same case we can consider that a charge Q is placed at the origin O, and another charge Q0 is placed at the point P, okay, at a distance R, and the direction of force exerted by the charge Q on charge Q0 is equal to F. Now as per the Coulomb law, we know that the magnitude of the force exerted by the charge Q on Q0 is equal to, so what is the magnitude of force? The force F is equal to 1 by 4 pi epsilon 0 into Q into Q0 divided by R square unit vector R, where R is the distance between the two charges and Q and Q0 is the 2 point charges placed at the point O and P. Now this is the magnitude of the force, and as per the definition we know that electric field E is equal to F divided by Q0. Okay, then if we substitute the value of F in this equation, what we will get? We will get 1 by 4 pi epsilon 0 into Q into Q0 divided by Q0 into R square. Okay, and Q0 and Q0 will be cancelled, and 1 by 4 pi epsilon 0 into Q divided by R square, unit vector R. So this is the magnitude of the electric field exerted by a point charge. The charge Q is a positively charged. Then the direction of the electric field produced by the charge Q, that will be directed radially outward the charges. Okay, like this. If the point Q is a positive charge. And what if the point charge Q is a negative charge? Then the direction of the electric field lines will be directly radially inward to the point charge Q. Okay. If the charge is positive charge, then the direction of the electric field will be radially outward direction. And if the charge is negative charge, then the direction of electric field will be radially inward directions. Now the significance of electric field. Electric field is an elegant way to characterize the electrical environment of a charge or a system of charges. Electric field is defined as every point in the space, and the concept of electric field help us to understand that what kind of force would act on a test charge if it is placed at different positions.